Okay, so in part 2, what I want to do is I want to break down and look at vectors and what's really a much more useful way to think about it, which is to think about the magnitudes of the vectors, which is how long they are, and the components, which is going to be how much in the x direction, how much in the y direction, which you could think of how much east or how much north or south, that kind of thing. So we've got a vector here, all right, up in this corner, vector A, and there's several different ways that we can notate these vectors. So the first is what we call the ij notation, 3i plus 2j. And what that means is we're going to go 3 in the x direction, 1, 2, 3, and then we're going to go up 2, 1, 2. All right, just like that. And that's where we are. So over 3, up 2. That's what the 3i and the 2j means. Now, we could dispense altogether with the I and the j if we use the bracket notation. All right, so the bracket notation is 3, 2, just like that. Means, of course, the same thing. Go over 3 and then up 2. Okay, now that is different than if we're talking about a coordinate. If I'm talking about a coordinate, then I use parentheses. If I use a vector, then I use the brackets. Okay, so watch out for that. Let's take a look down here. Then we might say, what's another way to talk about A? And what we might mean here is how long is it? What's its magnitude? And what's its angle theta? Okay, now when we say its angle theta there, we're talking specifically about this angle right in there. Okay, that's our angle theta. And so the way we get at that is by thinking about this thing as a triangle. Okay, and we already know this side is 2, this side is 3. We need theta right there, and so what we do is we use tangents there, and so the tangent of theta is going to be 2 over 3. Okay. All right. And so then if we work that out, the theta that we're going to get is 33.7 degrees. Just like that. Okay. And so our answer is down here. I got to get the magnitude still for you. Sorry about that. All right. The length of the vector, okay, just like with the triangle here, we're going to use Pythagorean's theorem. Like that. Okay, so that's 9 plus 4, that's square root of 13. Okay, there you go, just like that. And you can produce a number there instead of just, so we can just say this is 3.61. Okay, that's good enough. All right, so we eventually want something you can measure. And so working just with something like square root of a number like 13, a square root of a prime number, that's not very helpful. You can't exactly meter sticks don't work that way. Okay, so then when we get ready to specify our answer, we would say that it's this 3.61 at a direction of 33.7 degrees. Okay. And these are normally measured from the positive x-axis, all right? But as long as you know where you're measuring it from, it's fine. You don't have to get all... A lot of people all the time worry about, well, what if it's greater than 90 degrees? Whatever. Okay, as long as you can tell what it is. Woo, how did that happen? Let's make that bigger. I don't know what's going on here with my... my little thing here is out of control. It's way too small. How can I make it big? Hey, there we go. Okay. So now let's look at our scenario over here for B. All right, B is 6 units at negative 75 degrees. Okay, so that's what I was just telling you about here. It's okay. We can call that negative 75 degrees. It doesn't really matter. Okay. As long as everybody knows how we're talking about it, it's fine. Okay. Now we might want to know, okay, so what is the I component? What's the J component? Okay. Well, if we need to know that information, we think about it the same way, which is to say, as before, this is like a triangle here, except we know this side's 6. What we don't know is the horizontal side or the vertical side, but we know that this vertical side is 6 times the sine of 75 degrees here. And up here, we know that this is going to be 6 times the cosine of 75 degrees. And I'm going to pause this and grab that number real quick. Okay, so I got that for you. So 6 sine 75 is 5.8. 6 cosine 75 is 1.6. Okay, so then all we need to do is put in here that this guy is 1.6 and this is 5.8. Except that it's down. It's in the negative direction, so we got to make sure we put a negative on that. Okay. And down here, my other notation, I'd go 1.6 comma minus 5.8. Okay. There we go. Okay, let me zoom out on that so you can take a look. All of our nice work. Okay, so what if, like in this situation, we know we don't know the magnitude of A, but we know that we have the 6 is the y direction there, and on B we know we've got the magnitude here, but we don't know the angle. Okay, and we know we have the x direction here. Okay, so how do we deal with those situations? Okay, so pause this. Well, now I got to press forward here. Okay. Okay, so I'm going to scoot this over here. So I got a little room to work. Okay, we don't know how long it is, but we know it's 115 degrees. Now, I don't like thinking that way. It's not particularly useful. So this angle right here is 65. Okay, so now I've got my triangle. All right, I don't know what the hypotenuse is, but I know that this right here is 6. Okay. Ooh, not that one. Just kidding. Just kidding. This one is 6. There we go. Okay. So the 65 comes in super handy for us to get the magnitude of our vector. Okay. And I'm just going to use A to denote the magnitude. All right. A with a little line, that means my vector. Okay. So we know that the vertical side 6 is equal to A times the sine of 65, like that. And so if we need A, then we can just say this is 6 divided by the sine of 65. And let me calculate that for you really quick. Okay. Woo! Okay, we get 6.62 is what I get. Okay, so that's my magnitude. And then 6.62. Then we need the horizontal side, okay? And so I could use my magnitude, or we could use tangent, okay? So this side down here is A sub x, okay? So we could say that rise over run, 6 over A sub x, is equal to the tangent of my angle, 65 degrees. And so if we do a little bit of algebra there, A sub x is going to be 6 divided by tangent of 65. So 6, when we calculate that, divided by tan 65, gets us 2.8. Okay, and so in here I put the 2.8, and up here I put the 6.62. Okay, also 2.8, we could put that in here as well. Okay, now the other example here, Okay, let me do kind of the same thing here for you. So this time we know the magnitude. The magnitude of vector B is 10. What we don't know is its angle. But we do know that the y component, the x component, bx, is negative 7.5. Okay, so again, let's think about this as a triangle. We know this side is 10. I know this side is 7.5. So I can use the cosine of my angle in here. We call this theta. All right, and so 10 times the cosine of theta, 7.5, or cosine theta, 7.5 divided by 10. And so if we work that out, we go 7.5 divided by 10. And then I want to do the inverse cosine on that. All right, I get 41.4 degrees. Okay, so there's my theta value. Now, all I need to do is get my y coordinate here, and we could just say that 10 times the sine of theta is going to be my y coordinate, so I'll call that b sub y, like this. Okay, so 10 times the sine of 41.4, and that gets us 6.61. Okay, anyway, so you need to be able to do this kind of thing, to go back and forth between the different kinds of notation. Okay, find the magnitude, find the angle, find this component, find that component. Okay, and that kind of stuff needs to just be you want to be so good at it you don't have to stop to think about it. All right, this is never going to go away. We'll be doing this kind of thing all semester. Okay, and so it's important to get it drilled in and take ownership of it right now. Okay, so here we have a little problem. It says somewhere in Canada, a bull moose hears the call of a cow in heat and goes charging 10 miles across the tundra toward his true love. When he reaches her, he's some distance further north and 5 miles further east than when he started. How much further north is he? Okay, so what we do in a situation like this is we kind of break it down one piece at a time. All right, so let's say the bull moose is going to start here, and he's going to go 10 miles. So to get to his girlfriend, he's going 10 miles. All right, and so what we'll do is we'll draw a circle, and the radius of this circle is 10. Okay, then it says when he reaches her, somewhere on the circle, he's some distance further north. Okay, so that tells us he's got to be on this side of the circle. And 5 miles further east. Okay, so that tells us, that tells us he's on this side. Okay, and in fact, we know he is over here somewhere. And so turns out he is, in terms of a vector, it's going to have to be something like this, where we know the bottom side of that triangle is 5, and the top and the vertical side is, well, we don't know what that one is. Okay, so let's call this R, and we've got R, X, and R, Y, just like this. Okay, now we don't know the angle right there. Okay, so how can we get our head around this? Well, probably what we need to do is try to figure out, oh wait, you know what? Okay, we don't have to worry about the angle. We'll just pop this baby right out with Pythagorean's theorem. Okay, which tells us that r squared is going to be ry squared plus rx squared, just like that. And you can see right away where that's going to pop out. So ry squared becomes r squared minus rx squared. Okay, so we're going to have 10 squared minus 5 squared. That's my ry squared. So ry by itself, we're just going to take the square root of that. All right, so I've got 100 minus 25. That's the square root of 75. Okay, which is basically 8.7 miles. Okay, so we're 8.7 miles further north. Okay, so anyway, so vectors are handy in that respect. Now let me show you one more thing with vectors, then we'll be done here. If we have the components, and here's why this is so much more powerful. If we have the components, then we can add and subtract these vectors much more easily. Okay, so let's say we've got these 4 vectors, A, B, and C, that you can see there, and we want to add them up, A plus B plus C, and call that new thing A. Okay, so let's start off with A. A is a vector that's going to be 1, 2, 3 over and 1, 2 up. So A looks like this. B is going to be 1, 2 over and 1 down. So B looks like this. And then C is going to be 1 over and 1, 2, 4, 5 up, something like that. Okay. So if we're going to add these together, then what we're looking at is we're going to go A, B, and then finally C. Okay, so our solution goes like this. Okay, now let's break it down. So A was 1, 2, 3, 1, 2. B was 1, 2, and 1 down. And C was 1 over and 1, 2, 3, 4, 5 up. Okay, and so if we want to be able to say for our vector, what is our vector? Okay, let me put it in here just like this. All I have to do is say, how far to the right did I go total? Okay, so we went 3 to the right with A, 3 to the right with B, 1 to the right with C. So 3 plus 2 plus 1 is 6. So the x component for my resultant vector is 6. Then, in order to do the vertical things, we went up 2, came back 1, and then we went up 5. So 2 minus 1 plus 5. So that's 6 also. Just like that. Okay. Now, to find the magnitude then for r, I'm just going to do it for r. Okay, we'll use Pythagorean's theorem, 6 squared plus 6 squared. Okay, so that's the square root of 72. Okay, now don't give me this 6 square roots of 2 stuff, okay, because remember, we need to measure this thing. We need a number, all right? So we're going to get 8.5. Just like that. And then for my angle on r vector there, its rise over the run is going to be the same. So if I do my inverse tangent on that, then I've got the tangent of theta. Let me go ahead and write it out here. Tangent of theta is going to be the rise over the run. So I'm going to have ry divided by rx, which is 6 over 6. Okay, anyway, so that's got to be the 45 degrees there. Okay? All right, well, hopefully maybe this rounds some things out for you. Maybe it's useful to see me go through some of this stuff for you. There you go. All right, that's it for vectors.